Hello and welcome back to Statistics1, the data that we are looking at. So we are going to first, great. Network error occurred. Perfect. Let's values and their frequencies. Names. Oops, variable names. And then data given as, I'll just go Nick, Matt, Anna, and then another Matt, and then Steve, whatever. And let's put more names. Maria. I can't think of names. I should just look at, just ask you to give me your names, but whatever. And give me your favorite names.
Isaac.
All right, give me your 4 letters favorite names. Isaac, right? There will be like 15 cents. Tom. Thank you, Tom. There we go. Do we have any 3 or 4 letter female names so we can add them to the list?
Sue.
Anna is there.
Sue.
Sue? Who? Oh, Mia. I should remember that one. Have one of these at home. Anything else? That's good enough, all right? So we have 10 names. 10 names. And if you look at this, each one of these names, except Matt, is featured only once. And we have 2 Matts, right? So they will hopefully have different last names, right? So it's easy to sort them out. So the frequency of Matt is 2. And the frequency of every other name on this list is 1. And that would be a way for us to organize the data. So what they have in example 2.5 in a textbook is the data for 40 students in terms of their political affiliations as Democrats, Republican, or other. And the list just has, it goes Democrat, Republican, Republican, Democrat, Republican, Republican, other, Republican, Republican, Democrat, Democrat, Republican, Democrat, Republican, right? So you see that they're all mixed together. But then you simply say, all right, there are only 3 categories that we have to worry about, which is Republican, Democrat, and other. And then you just count the frequency of each, i.e. how many of each we have. So in this example, it worked out to have 13 Democrats, 18 Republicans, and 9 other in this particular classroom. So this was an example, and then obviously the frequency has to add up to 40. Now the method to organize this quickly is to create a tally so that you can quickly go and count the amount of these. So in the particular example, so example from the book, we had 40 students, and the chart at the end looked like this. Party, tally, and frequency. For frequency, we can use lowercase f. So we had the Democrats, Republicans, and other. Now, for the tally, for Democrats, we had tally like this, which is 13. So you go 4, then you cross it with a fifth, and then you go 4, cross it with a fifth. For Democrats, we had 18, so it's going to be 3 groups of 5 and then 3 to give us 18. And for other, it was 9. So you go 5 cross 1, 2, 3, 4 for 9. And then you can actually see that the total is 40. So that's the total amount of students that the tally has to add up. And this is the standard chart. You will have your variable, then you will have your tally, then you'll have a frequency, and you have to make sure that the frequency adds to 40, which is the number of observations you made. Remember that observation is one data at a time, one data point at a time. And now we're going to define relative frequency, which you can also understand in terms of the percent. We can convert the relative frequency, can be represented as a decimal or as a percent. And you will be able to say that this much percent-wise, this much is affiliated with Republicans and Democrats and other as you go move along. So we're going to start with relative frequency distribution. So relative frequency distribution of qualitative data is a listing of the distinct values and their relative frequencies. Now the formula for calculating relative frequency, and this is important. You said this is, oh, it says purple. Okay, someone said magenta. No, this was a plum. Whatever. Learning my colors. Indigo. Oh, whatever. Should we do indigo? Nah, I'll do. So the formula for relative frequency is frequency divided by number of observations. So relative frequency distribution is a chart of all relative frequencies. To get a relative frequency, you divide frequency by the number of observations you have. So now, our chart is, from the previous example, is going to have an extra column. So we are still going to have, as you can see, this time I put the effort into a chart. It looks good. So this is the party where we have Democratic, Republican, and other. Then we have our tally. All of this stays unchanged, obviously. Now we have our frequency, that's the lowercase f. All of this stays unchanged. And here is the new column now. New column is for relative frequency. We can call that RF, relative frequency. So tally was Democrats 13, so 2 stack of 5 and 3 of these, and then we had, if I remember well, 18. And then a 9. Now, relative frequency is going to be 13 divided by 40. So that's the first one. And then you keep 3 decimal points after the 0. So that gives you enough, I guess, precision. 13 divided by 40 is going to be 0.325. I think my battery is dying in this pen. It's like one thing after another. Then we have 18 divided by 40, no coughing, is 45. Oh, come on. Really? Let's just go home. I can write 5. Maybe if I got it right, there we go, perfect. Got it. And finally, 9 divided by 40 is, yes. So 0.225. So we have, maybe I should just, I'll write all of these. So 18 divided by 40 is 0.45. And 9 divided by 40 is half of that, 0.225. I just want this to work. I think it's... Might be issue with the screen there. I will take a look. So that's what we have, and we know that we can transform these into percent now by moving the decimal point 2 places to the right. So you can write relative frequency as 32.5%, 45%. Yeah, I probably have to restart. Let me just reconnect the pen. Every day there is a different issue. So annoying. So 32.5%, 45%, and 22.5%. And you can represent your frequency either as a decimal or as a percent. Now, mainly we use the percent, right? When you read papers and stuff, data, it's generally in percent. So I would say that, 89% of the students were successful in Statistics 1 class, right? Which leaves us with 11. Right? That's the way you read that statistic, which translates to 2 or 3. So relative frequency distribution. Now we can represent this data in a pie chart as well by assigning the slices, larger slices to the larger percent, smaller slices of a pie chart to smaller percent. So the largest slice of the pie chart, almost half, would be 45%. Now this is what we are going to do now. We're going to take a look at some of these done directly in Excel, which you guys should be able to do. So let me get Excel. We're going to start a new document, and I'm going to type in data here so that you can see exactly the way we make the pie charts. So this is the Republican, and Republicans had well, I'm going to type all the data. The way it was in the book was Democrats first. So Democrats, Democrats, there we go. So Democrats were at 13, Republicans were at 18, the other were at 9, and you can actually get everything else computed by Excel if you use features of Excel. So you can just simply add these using the auto sum, and it will give you 40 as a total. Let me just make sure that you see everything that is happening over here. So what I did is I typed in all of these, but the 40 was not typed in. 40 was added. So you select these guys, and then you go extra row where you want your answer to be, and you click over here in the upper right hand side, auto sum, and it gives you 40. Now, in this cell, I want the relative frequency, and the relative frequency is the formula where I divide 13 with 40. So what I'm going to do is I'm going to write equals, and I'm going to push this cell, and it puts in a C4, which is the cell C4. So it will take the value from that cell, and I'm going to divide that by 40 in my formula. So divide by 40 and push enter. As you can see, immediately gives you 0.325, which is the percent for Democrats. And then you can actually just copy the formula for every other row without typing it. That's why you didn't go 13 divided by 40. You went C4 divided by 40, because now you see how you have this big fat plus for a cursor, and then you go in a corner and it changes to a little tiny plus. So when it changes to a tiny plus, you can grab that corner and just slide it down, and all of the other ones will fill, and clearly they have to add to 1, which is 100%. Now you see your percents. That's a 32.5%, it's a 45%, it is 0.22, right? Now, yes?
Just a quick tip. You can actually just double click when you get that little positive.
Double click?
Yeah.
For the
It will
entire?
filter down.
So, it didn't give me 1 at the end. Ha! That's okay.
It didn't give you the 1, but you can also not have, you don't have to
I got
actually type in the 40 either.
Oh, really?
No, you can actually do divide and click on cell C7.
Nice. That is Excel skills. Equals
Yeah.
C4 divided by C7. I said C7. Enter. And then select here.
Yeah.
Little plus.
You have to put in the before go back up to D, the first one. Put in a $sign in front of the C.
$sign in front of C7. Okay. So now that's in dollars. Good. And then I go a little plus.
That's enough.
It's probably
No, I think it's just, yeah, it's picking up the next line, which is C8. That's what I was afraid of.
Yeah. Yeah, I'm sorry. Put the $sign before after the C.
Oh, C$7.
It's C$7. Yeah.
Okay. C$7. Okay.
Yeah, I
No.
tend to flip those for some reason.
That's okay. This is okay. Now let's see. Magic. Nice. I learned.
That's especially good when you have a lot of data.
Which you are going to have for your project. So I hope that this little excursion of me learning this actually, like when you have to go scroll 150 and then you miss 2, and then you say, okay, 149 is fine, 148 is fine. Change that everywhere in the paper. So yeah, all right, time for pie chart. Let's see if we can achieve that one. So I'm going to select data here. I have Democrats, Republicans, other as a variable, and then their frequencies, 13, 18, and 9. I select only that part, and then we go into insert, and there are the pie charts right here. You have all of these interesting, we're just going to do the vanilla one, and there we have it. Now you can go and actually modify, beautify your chart up there. But as you can see, the Republicans have the biggest slice, which is almost half of the entire, because they're at 45% in this case. You have the legend here, which is the other Republican Democrat, but you can change that as you change the type of the chart on top. So some of these are going to lose the legend because they're going to put the data right on the pie chart. This one gives you the relative frequency along with colors, and right, so you can play and pick different values. Again, all of this is part of your project, and believe it or not, 50% of your project is math, and the other 50% is writing and design. Exactly. So writing and design will be another 50%. So this stuff is very important because this course is about understanding, presenting the data. And if you're not able to do that, you're not achieving goals of the course. Yes?
You mentioned someone who used crime statistics from their local police station.
Yes.
Would it be frowned upon to do that again?
No. You can do whatever. You can do whatever data. I mean, generally, maybe even 1/3 of the entire classroom would use some types of sales. So that's okay. Imagine if someone in 2010 used sales, and I said, that's it, we had that. And then another person said, okay, I'm going to look at quarterbacks or whatever. I said, oh, yep, great. So you used up all the ideas in 2010, so good luck in 2018, right? So yeah, you can use whatever. I told you the infant mortality was used, general death was used, car accidents only, the police reports, sales data, sports data of all kinds, warehouse storing stuff, divorce rates. You come up with what concept you're interested with, get the data for at least, 2 months, but, if you can get 100, 150 data points, that's even better, if you can. Yes?
Is the outline on the website? Like the outline of this project?
No. No.
Nowhere. There's no outline.
Yeah. I just told you, get the data and just run every concept from the book against it. So far, I hope that you already are thinking about what type of data you want. And the only thing that you have about your data so far to say that your data is quantitative, and then whether it's continuous or discrete, right?
Can you say that again? Like the project, like this project? Let's say it again. That's what I want to write down.
You pick the data that you like, that you're interested in, and you run every concept from the book against that data. So we are going to learn a whole bunch of stuff. So eventually mean, median, mode, and standard deviation, and everything that we do in the book, you just run against that data. And I told you the way to save yourself from crying at the end and pulling your hair that you pay money for. Yeah, you do, right? To go cut it and style it and stuff. So to preserve that, look, just get the data as soon as you can. So as we go along the class, you just apply the concept you learned today to your project data, and you keep compiling that so that in last week you can just fill in the text in between, put in some cute pictures, put up the cover page, and that's it. Rather than doing all of the analysis and everything 3 days before the final, screaming that life is bad. I know it is. Yes.
Do we have to apply every concept to every data point, or do we have different data points that have better applications for concepts?
Just one data, and then certain concepts might not be applicable. So you will state that in a sentence that it's not really applicable to do probability distribution, blah, 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 to this particular set of data. Or someone else will have that as the primary thing and not have the other. So yeah.
Let's say you're doing like if it's like a YMCA and it's like how many people are
visiting per day
gonna come like in a year or something. Well, that's like one concept, right?
That's
really
365 data points. Good.
You can't really do like a pie chart from that though, right? Would a pie chart work for that?
You would, because you have the swimming pool, and you have the weight room, and you have the. Oh, okay. So you say 45% go to the gym, and then 2% go to the pool, and right.
Gotcha.
There's a 7% of people just go in and just look, and then they leave and never come back, right?
Yeah.
Exactly. I know the data. Good. All right, so that's the project. There was a little tangent there, but yeah. Just sit and think the ways that you can, sneak these things in. So we see the pie charts. We can also get the bar charts and all different kinds of charts that exist in the. So I'll just move. I'll move this one. We're going to make it smaller. No. Just want to move it here. We can also go insert, and then we have various bar charts. So column or a bar chart. And clearly you can make them, pretty with the 3D effects and everything else. You have to understand that it has to be clear to read. Sometimes you have to sacrifice some of aesthetics in order for it. This is important in statistics because we have to read and see the data clearly to make good decisions. Remember the stop sign we talked about over there? So you should never use cursive fonts for your resume, because when you apply to a position that has high frequency of applicants, right, which means a lot of people applied, they're going to stuff your resumes through the scanner machine to pick up the keywords. And if your font is all cute and sparkly, the machine is not going to pick that up. So instead of the track of, okay, let's check this person out, it goes to the track, shred this. Right? So, yeah, it splits like this after the machine, right? So, after the scanner. So, you can't use anything that is cute and fancy and flashy in the resume, because most likely machine is going to read it. And also, I mean, you have to consider the people's pure vision and their age and stuff when they're looking at these things. So you might have someone from 1920 looking at your resume, and you have a cute font there, and it's like, right, what is this? So just do yourself a favor, about 12, 13, 14 font. Default one that Microsoft gives you is going to be just fine. And then you show up and talk about things. So we can do pie charts, we can do bar charts, and as I said, just make sure that whatever you do, guys, make sure it's clean, it's visible, so we can make it cute, but then at the same time, what's better in terms of seeing this? I don't really see the percents. I mean, the software really tried. But as you take a look at these numbers over here, it's difficult to see that that's 13, that's 18. And then for people who are, you know, spatially challenged in terms of reading these things, they're not going to see. They look at this box, and it looks like it's below 10, but it's not. This is 13. When you look at it from this perspective, right, because the way you look at it, right, this is actually 13. So it's parallel to this part right there, but in perspective. And if you look at this one, right, this one goes over 15, it's 18. Well, 18 is pretty much here. So you see that, you know, for me, this is clear, right? Because I'm used to dealing with 3D models and rotating things in 3D. I teach calculus 3 after all, right? So every semester. So for me, that's not a problem. But for majority of people, it's a problem. So you can't use the cute one, right? Just go with the vanilla one, right? Because this one is going to show the data. It's clean, right? You can change colors and make it cute that way without the 3D effect where people go, well, the graph shows 10, the text shows 13. This person has no clue what they're talking about, so bye, right? Because there's a next one with this kind of graph that I get this, you know, fast. And that's important in the work environment. So when we do assessment for this class and we look at your scores at the final exam and learning outcomes, none of our graphs are cute and throw-dimensional and spaced out, right? Because you need to present that data and give it later to the state and middle states and accrediting institutions so that you can eventually transfer your courses, right? We have to go to those things. So this is the way we pull, and I can probably bring in one of the reports so you guys actually see what a professional report looks like to present the data and its statistics. I'm actually working on one right now for Calculus 1 from last semester. So Democrats, Republicans, other, you see the frequencies listed. You can go in a design and you can change that to percents because you can read 13 off of the background chart, right? So all of that is available to you. And rule number 1, the lecture is over, that's it. So rule number 1, rule 0, whatever you want to call it, clean, clean, clean. You have to be able to see it instantly and to be clear of what's presented.